Hello, I'm Ji-Hok Choi from Korea Aerospace Research Institute. Now I'm presenting comparisons of modeling atmosphere and observation data between range of 0 to 300 kilometer altitude for reentry utilization. Table of contents. First, necessity of research is of vertical distribution of upper atmosphere. Second, reentry of space vehicles. Third, development of new combined model of upper atmosphere. And fourth, vertical distribution of physical and chemical properties from combined model. Fifth, comparison between model and observation data. Sixth, conclusion. For the first, necessity of research is of vertical distribution of upper atmosphere. In Korea, in the third space development basic promotion plan, the plan mentioned re-entry study from 2021 and asteroid sample return mission in 2035. The upper atmosphere between the height 0 to 300 kilometers is so that the region it would not be related with weather phenomena, and it was very difficult for in situ measurement except sounding rocket which could put probe directly. The atmosphere height between 20 to 50 kilometers is called the stratosphere, in which temperature is rising with altitude due to ozone concentration. So the stratospheric region is very stable in fluid dynamic sense, and it becomes also heat source in the middle atmosphere dynamics. In contrast, the atmospheric region with altitude between 50 to 90 kilometers is called the mesosphere, in which temperature is decreasing with altitude. So the region is fluid dynamically unstable to occur convection, turbulence, and gravity waves. At the height 90 kilometers is the coldest region called mesopause. And also in the region of height 70 to 80 kilometers, the maximum aerodynamic heating occurs during re-entry of space vehicles. In the height between 80 to 200 kilometers, atmosphere becomes stratified and ionized, and the temperature rises from 200 K to 1000 Kelvin sharply due to increasing fluxes of space, cosmic ray, and ultraviolet radiation from the sun, which region is called lower thermosphere and ionosphere. In this region, there are large quantity of electrons and protons from the sun and cosmic particles from deep space. Then it produces a huge heating, so it also causes planet-scale convection circulation. The heat radiation and cosmic particle transport through transparent mesosphere into lower atmosphere to affect the stratosphere. Finally, it may affect weather and climate system. However, the researches on this topic are not abundant. We could see general view of upper atmospheric vertical distribution of temperature and pressure. We could see in lower troposphere, the temperature decreases with altitude, and in the stratosphere, due to the ozone heating, temperature rises, and in the mesopause region, temperature decreases. In beginning of thermosphere, temperature rises again. In second, reentry of space vehicles. For many regions, we try to make reentry. For example, a deep space exploration space vehicle reentry with a maximum speed of Mach number 40, because it is very high entering speed and relatively small scale. And the other thing is low Earth Orbit Transport Space Shuttle reentry with a maximum speed of Mach number 20, because it shows rather small maximum speed because of the big body size of the space vehicle, and also lower entering speed. This shows the typical velocity versus altitude of reentry space vehicle. From the space vehicles from the deep space exploration missions, it shows very high uh, reentry velocity because of this small scale of size and a very high entering speed. It shows the maximum speed over the Mach number 40. So it needs ablative thermal protection system. In contrast, in low Earth orbit, reentry vehicles such as shuttle, it needs reusable thermal protection systems because of the rather lower reentry speed, less than Mach number 20. It shows a typical aerodynamic heating with altitude of reentry space shuttle. It shows maximum heating occurs at altitude between 60 to 80 kilometers. And then it continues around 20 minutes of communication blackout. Third, development of new combined upper atmosphere model. For design of a thermal protection system for a reentry space vehicle, basic information is the vertical distribution of atmospheric physical and chemical properties between the height of 0 to 300 kilometers. Because of producing the atmospheric data set between height of 0 to 300 kilometers, it is required to develop an atmospheric model to produce the necessary data set. For development of a new combined upper atmospheric model between the altitude of 0 to 300 kilometers, the existing two models are used, such as American NRL MSIS and European ECMWF. NRL MSIS and ECMWF are empirical models which could produce data set for temperature, density pressure, and other chemical species of atmosphere, such as oxygen atoms, oxygen molecules, nitrogen molecule, so on. The new combined model is using the Python language and covered the range of latitude 40 degrees south to 40 degrees north, longitude 120 east, 180 degree east, 5-degree interval. Altitude range is 0 to 300 kilometer, 5-kilometer interval. And based on 11-year data, which related to the solar activity cycle, the region is sought the trajectory of a Korean reentry vehicle. Our model is combination of two existing models, NRL MSIS and ECMWF. So NRL MSIS covered the higher altitude over 80 kilometer to 300 kilometer, and ECMWF covered lower altitude such as ground to 80 kilometer. Basically, we produce data set and interpolate for the point to which we have interested in season and daily time and geophysical location. It shows the typical data set above the Korean Peninsula from the MC's uh, models, the temperature and mass density and variation with altitude. This shows the data from our combined model, the temperature variation with the seasons and latitude above Korean Peninsula. It shows the pressure variation with the seasons and latitude. It looks not very much variations with season. This shows the monthly mean meridional and meridional wind velocity, zonal wind velocity. It shows big variations. It shows the upper atmosphere temperature variations from the combined model. It shows the in the higher altitude above 100 kilometer, it shows the big variations and big uncertainties. So we need more studies in the future in the higher region of our atmosphere. This is the comparison between model and observation temperature data. It shows a rather big, good match with the our combined model and actual observation data from the satellite. The satellite is the EOS Aura satellite with the microwave rim sounder. Especially in the higher altitude over 80 kilometers, there are some discrepancies we could see. Also, in June, we could see some also discrepancies. Also, some discrepancies in the December. I think that it causes from uh, due to the solstice. Yeah. This shows uh, the pressure with altitude. It shows a very good match seasonally. In conclusion, the basic information for design of thermal protection system of re-entry space vehicle is the vertical distribution of atmospheric, physical, and chemical properties between altitude of 0 to 300 kilometers. To obtain the information, a combined model is developed based on the NRL MCS model and ECMWF model. The maximum aerodynamic heating during reentry occurs between altitude of 60 to 80 kilometers. On March 21st, year 2017, at a height of 80 kilometers, where the physical and chemical properties above the Korean Peninsula are as follows. Density, for example, 1.773 10 to the minus 8 gram per cubic centimeter. And temperature is 200.5 Kelvin. The comparison between combined model and satellite observation data shows a good match, but some discrepancies in a certain season, such as June, and at higher altitude around 100 km for temperature. The combined model could produce simulated vertical distribution data set according to latitude, longitude, season, daily time, and solar activity. The data from combined model could be used valuably for design of re-entry space vehicles, TPS, and also study long-term climate and weather system. Significant variation and uncertainties exist in higher altitude above 100 kilometer height, so more research are required for the region. The interaction between upper atmosphere above 100 kilometer altitude and lower atmosphere below 100 kilometer altitude maybe exist, but it is not clear. So that research is necessary for understanding climate and weather changes and progresses of global warming in the future.